All right, so today we are talking about transformations and how they are much, much more than meets the eye. When we're talking about transformations, we're talking about ways that you can move a shape on a coordinate grid. The first way that you can do that is a translation. A translation simply means moving without turning or flipping. You take this shape and you're simply sliding it to a new spot to create a new image. You can do that up, down, side, side, or a combination of both. The next way that you can transform a shape is to reflect it. Reflection occurs when you flip a shape over a line of reflection to create a mirror image. So you can see here, flipped over to the other side. Lastly, there's a rotation, and that occurs when a shape is turned about a point, so either on this shape or on the coordinate grid, and then that turns either clockwise or counterclockwise to create a new image. We'll take a look at a couple examples of those a bit later. But what the heck is this? That simply is prime. This little tick mark is the symbol for prime, and what that shows is that something is a copy of a shape. When we copy a shape, we call the new shape, instead of saying shape number 2, we call that an image. So this shows that something is an image. If you see that, it's not an original, it's a fake. It's an image. So if you have your original, there'll be no those tick marks on there. It'll just be like alpha or A. And then you see A prime, that means it's the first generation copy. It's been copied again. A double prime, and yes, A triple prime. We won't go too much further than that for safety's sake. Now the fun part that you all will loathe, describing transformations. So it's not enough that you understand those three kinds, you have to explain them when you see them in your math books. For a translation, that was the slidey slide, you need to tell the direction, up or down, left or right. This will be your favorite one because it is kind of the easiest one. An example of that would be to say the shape has been translated 2 down and 4 right. So if I look at my beautiful coordinate grid over here, so pretty, a little bit wrinkly though, and I place this shape right about here. If I want to go 2 down and 4 right, it would be like this. And then 1, 2, 3, 4. So in your book, I still stick to that. Okay, so in your book, if it asked you to say, hey man, the original was here, now it's here. Can you describe that? You would say, of course I can. This shape has been translated 2 down and 4 right. You've moved 2 units down and 4 units right. Okay, sounds not too bad. Getting more difficult. Reflection. For reflection, you're going to need to say which axis the line of reflection is on. Is it on the horizontal axis? So it would look like this. That's a line of reflection on the horizontal axis. Okay. Is it on the vertical axis? So it could be anywhere. And yes, sometimes, not too often, but you might see one of these. And it's when you have an inverse reflection, a diagonal reflection like this. But don't worry, those don't happen too often. Okay. And you need to say which point the line is placed. So if I place this here, you can see where it is placed. In my example, I could place my shape like this. Okay. Poorly. Okay. And I would say this shape was reflected through a line of reflection at 5 on the horizontal axis. So over here, what I would do is I would, if I was like reflecting this thing, which I'm going to do a poor job of, I would have a reflection that was like cacao. Oh, I've already botched it, but you get the idea. Okay, so this would show a reflection at 5 on the horizontal axis. because it's at 5 on the horizontal axis. So again, you have to state what it is, reflection. You have to state where that line is and on which axis. Those 3 things. The last one is a rotation. So this one seems like it's easier, but it's a bit tricky because there's degrees involved. So you're going to tell if it's clockwise, if it's counterclockwise, and then how many degrees. Please ignore these splotches. Yes, I made a mistake. Doesn't happen often. Oh, yes, it does. So is that 90 degrees, a quarter turn? Is it 180, a half turn? Is it 270, a 3/4 turn? Or is it 360, a full turn? Now, when I'll move this thing like this. So when you're doing a rotation, the shape could rotate on one point that's on the shape. So you could actually have it rotate on a corner of the shape. So if I was doing a rotation that was 90 degrees counterclockwise, I might be rotating on that corner there, and it would just kind of be like this. Okay, that's a rotation on a point on the shape. However, you could also rotate on a point on the coordinate grid. So I could make a point, well, we could do like this here. And I'll move my thing a little bit. Okay, so we can move, we could rotate on this point here, and that's when you'd be rotating like this. You're rotating off that point, as I do a poor job of that, okay? Maybe I'll make it closer here. I'll make another point. So if we have this here, okay, I'd be rotating on that point. So if I did that one, that would be a 90-degree rotation counterclockwise, and I could call that point B for Bakey. All right, so this one you have to be really careful. It helps to have a protractor or to try and visualize that turn. So there you have it. Transformations, and like I say, much more than meets the eye. I recommend reading carefully instructions. Watch the video again. You might learn something. Thank you.